All right, so week 10, second last week, almost done. At least the attrition rate's gone down. We're don't feel losing people, but still got people writing the quiz every weekend, which sort of is an indication that they're still interested. Class attendance isn't great, but sort of, I don't know how many people actually watch the YouTube video afterwards. There's not too many people live on the Wemba on and Werner. All right, so quiz wasn't too bad, 84%. I said the interceptor stuff isn't difficult. It's just you just need to. It's pretty straightforward. That's a few things you need to know about it. So, looking at the bottom 3 or bottom 5 questions. Let's see what question number. Question number 3. Just the following exceptions can be found from a lifecycle callback method of an interceptor. So it's like any other one. So it can't be any application exceptions because it can't be a checked exception. So it can't just be any exceptions. So that's out. It can throw exceptions. So the bottom one is out as well. So anything that you can throw from a normal lifecycle callback is a system exception. And generally, if it's like on a stateful or stateless bean, that'll just kill it. So it's just something that you just need to know. So basically with the interceptor stuff, the interceptor bean or the interceptor and whichever bean it's attached to usually go hand in hand. Whatever the bean can or can't do, the interceptor bean can do. So even though it's a lifecycle callback for an interceptor bean, it's still just a lifecycle callback. Then question 12. This is an interceptor method on a bean class using a round invoke is always the first method to be invoked. No, it will be the lifecycle events. So it'll be your post constructor that doesn't have an around invoke. So if you've got an interceptor that's also got a post construct method, it'll be called before the normal post construct method. But this question specifically asked using the around invoke annotation. Then question number 2. And this is you have associated interceptor class with a stateful session bean method. This method is called once by 2 different clients. How many instances of the interceptor class will be created? So this is a stateful session bean. And because the interceptor classes and the beans that are attached to go together, because it will be 2 stateful session beans, it will be 2 interceptor beans. So that's 2. Now is the question a bit funny though. Like one method being called once by 2 different clients. It actually sounds like it's only one bean or one client. So I don't know if they're asking it like that to confuse you. And 14. Says calling precede in invocation context proceeds to the next interceptor in the interceptor chain. So that's just true. I mean that's what happens. So it's either going to be the next one in the chain or it's going to be the actual method, whichever one. But that's true. And then 17. A single session bean is discarded if a system exception is thrown from the interceptor chain. So the only time a single session bean will die from an exception is if it's during the invocation of it. So in this construct or its post construct. So if it's anywhere on the around invoke or something, it's not going to matter. If it's a system exception from even a business method on a single domain, it's not going to die. It's going to keep on running. So the answers here is discarded is false. So it won't be discarded. You can probably argue the fact and say, well, what if it wasn't the intercept method from the post construct? Yeah, maybe. But so if it in the questions they don't specifically mention it, and I think this is an R for Rory question, but in the exam I think they'll be more specific about it. All right, so that's, I mean, most of the other questions, everybody either got, maybe one person got it wrong, otherwise everybody else got it right. So it was just those few questions. So that's it. So this week we're looking at transactions, and then EJB exception handling is like this last little topic they've got like at the bottom of the list. And a lot of the other sessions or other topics has a bit of exceptions in there. You need to know about it. So You need to have exceptions from them. This is just like a last little bit, which is sort of common for all of them. So I'm just going to do one little slide about it. So when it comes to transaction management, you're going to have the concept again of like container managed and bean managed, like we had with the concurrency on singleton beans. And they like to intermix it in the exam, and so you know the difference between the two and when to use one and when not to use the other one. So you can see, so that's sort of around the container, taking care of your transactions, and also the JTA. I've just added in there. All right, so before we get into how transactions work in the JE space and EJBs, it's going to sort of get into the basics. So if you know about this, then you can forward on the YouTube video for like a minute or so. So in sort of JE speak, a transaction is a grouping of tasks. So you've got 2 or 3 or 5 things that need to happen, but if any of them fail, then the entire thing needs to fail and roll back. So nothing needs to be committed. And then when you talk about transaction, you've also got the whole thing around asset. I can't remember the guy's name who did that, but it was like in the 70s or something. The whole thing around atomicity, consistency, isolation, durability. You can go and Google this up and read up about it if you want to know more about it. So in the EJB world, when you're looking at these different tasks and where transactions plays a role, it's stuff like SQL statements, JMS messages, or when you're interacting with an external system which sort of supports transactionality. And then this normal business enterprise applications lends itself to transactions. I mean, you don't want to have a case where you're doing banking or booking a flight ticket and then everything works out and you've got your stuff in your stuff, but then if you go to the bank, then there's no money in your account, but you didn't draw any money. So any type of business application will have transactionality in it. It's just the way it works. You can't write a business application without transactions.
I was thinking we're going to use an example like a flight controller, that you want the plane to go X and you really need to.
So with EJBs, there's 2 options when it comes to using transactions. The one is doing it programmatically, using bean managed transactions, or doing a declarative one using container managed transactions. And it doesn't matter which type of bean you use, message driven or session beans, you can use bean or container managed for both of them. And the other bit that you just need to know around transactions is 2-phase committing, and that sort of relates to distributed transaction management, which I'll get to next. And that's the idea that if you've got a few systems, so you've got like 2 or 3 databases that are or SQL statements which are sort of in the same transaction, before that commits, the way 2-phase committing works is that the transaction manager will go and say, listen, is everybody ready to commit? And if everybody says, yes, we're ready to commit, then it commits. So 2 phases. So is everybody ready in actual commit phase? So where that comes in is in your container, you've got your bean, and you've got a transaction manager that sort of orchestrates all the transactions around there. And this transaction manager can either be part of your container, or it can be an external tool. It doesn't necessarily need to run in your container. So when you're looking at sort of a distributed transaction management, you've got the idea if you've got a bean, and the bean only interacts with the transaction manager or your beans. And they don't care about what is underneath there, how transactions works, and that's sort of done through your JTA or your Java transaction API. So that's how your bean interacts with your transaction manager. Transaction manager then orchestrates the different resource managers, and the resource managers are responsible for the actual transactions, so rolling back, committing, doing the voting on the 2-phase commit. And that's one thing you'll sort of see when you're working with containers and so on, is you've got sort of these XA type data sources or JMS, and that XA is sort of means that your resource manager sort of can talk to the transaction manager and can take part in this distributed transaction management. And also sort of see if you're using any drivers like an Oracle driver or SQL database driver, then they'll also have, like in the namespace, we'll actually have the .xa in the namespace to tell you that it's part of that. Then some other stuff around the EJB transaction stuff, so JTS, Java Transaction API, so that's how your bean talks to the transaction manager. We've got the JTS, which is sort of old school, which is sort of talking between core bus servers. The Java connector architecture can also take part in that, and then like I say, XA is sort of this mapping that allows the transaction manager to talk to different resource managers. Sorry? locking.
So it blocks other queries from running.
Yeah, so it's more around the way the transaction manager talks to. So distributed transaction management is two components: the transaction manager and your resource manager. So resource managers, the XA there is just for transactionality. It's for taking. So the resource manager knows how to talk to. Transaction manager knows how to talk to that specific resource manager. So I mean, the resource manager can do other stuff as well, but the XA is more for transactionality, so that I can take part of transactions. All right, so first looking at container managed transactions. So container managed transactions is you go and mark a method or a class, or actually a class as transaction management as container, or you can set up in the deployment. What's the XML? EJB.xml, deployment descriptor. That's what I'm looking for. And the way that works is you just tell the container that, listen, this bean is taking part in a transaction. You don't say when the transaction commits or rolls back. So those boundaries for the commit and roll back is actually set by your by the container, and it's sort of marked where the business method starts and ends. So if you come into a method, the transaction starts. When it exits the method, it commits. So you don't tell it where to commit. You can tell it where to roll back, but you don't tell it where to commit. So those are sort of the boundaries. And you can only apply that transaction management type at class level. So you can't have a class and different methods, one being bean managed, one being container managed. It doesn't work like that. It's either all or nothing. Then when you're using container managed transactions, to tell your methods, you either need a method needs to either be part of a transaction, not be part of a transaction, start a new one. You apply a transaction attribute. So your transaction attribute you can apply at a class level or method level. And that just tells your container how you want that method or that class to take part in the transaction. So you've got 6 different attributes that you can use. So the default is required. Container managed transaction management is also the default for Bean. So if you don't specify transaction, what type of transaction management is going to be container managed. And if you don't specify transaction attributes, it's going to be required. So what required means is if a client calls your Bean and the client already has a transaction running, your Bean will just take part in that transaction. It'll just say, well, I'm part of that transaction. If a client calls and your Bean isn't, or that client isn't started a transaction, then your Bean will start a transaction and commit it when it's done. So for the exam, these sort of 6 things are, when it comes to container management, which they like to ask. And the type of scenarios and type of questions they'll ask is, I'll give you a scenario, and they usually draw these little pictures where they've got the different beans and clients calling each other, and each one will have a different transaction attribute. And they'll sort of say, okay, well, which one will create a new transaction? Which one will partake in a transaction as really, which one won't use a transaction? So you'll need to know this. Or they'll give you a scenario and say, these are 3 different beans. This one created a new transaction. This one didn't take part in a new transaction. This one used the same transaction. What attribute could be on that specific bean? So these 6 things are just what you need to know. And when it comes to container managed, this is, yes, I will say, I want to say 80% of the questions on container managed stuff will be about these attributes and different variations of them. One thing just notice that you'll see, and I'm not going to go through these, but on the study notes as well, the different types of beans and different types of methods can have certain of these attributes. So like a message-driven bean can only be required or not supported. It can't use any of the other ones. So this is something you need to know. Then stuff around the never supported and so on, and when a bean managed bean calls a container managed bean, how that works, just need to know that. So another thing you need to look out for is the not supported one. So that's if your bean, and the only time we'll use that is if your bean is calling some other resource which doesn't know about transactions, can't take part in transactions. And if it does, it's going to throw an exception or something. So that's the only time we'll use not supported. Most of the time we'll use required. And if it's a mandatory, it's the other one. So that's sort of listen here, this needs to have a transaction, otherwise it's not going to work. So something like if you've got a system that has to do some of the credit card transaction, you probably don't want that transaction to be on its own. You want it to be part of the bigger transaction of actually ordering it and processing it. So that's really something like mandatory. Actually, never is the one you'll use if it doesn't support a resource, sorry. Not support as if it just doesn't matter, if it's there or not. Then on container management, you can't necessarily say when it needs to roll back, but if you have something like an application exception, so something that's gone wrong with the application, it's not a system exception, nothing has crashed or anything like that. If you've got an application exception where something like a guy draws money on your way of saying the guy doesn't have money to throw an application exception, the client isn't going to, that application exception doesn't roll back a transaction. So you actually need to tell the client, listen, yeah, something happened, you need to roll back. And the way you do that is by calling the set rollback only method on your EJB context. So that pretty much tells the container, listen, if something bad happened, do not commit this transaction. So even if the client calls commit, it's not going to commit it. The only thing that can happen is that the transaction is going to roll back. You can only use the set rollback only if the attribute you used on that method or class is required, new, or mandatory. In other words, there's either an existing transaction or you create a transaction, or either pretty much the transaction came from outside. So there's a running transaction from the client or a possible running transaction from the client. And one of the things to look out for is if different beans, so the set rollback only isn't going to stop the process. The process is going to go on. So if something happened, it can still go and call another bean. It's also part of container managed transactions. So there you can go and say get rollback on and see if somebody's actually set the rollback only method. So if you've got something that's going to be resource intensive or it's going to take a while, before going down that path, you can just see, listen, you know, something up the line, not called rollback already, and you can stop it there. So just to make your application a bit more robust. So when you do a two-phase commit, the transaction manager is going to say, okay, well, we have to roll back, and it's not even going to ask the guys, it's just going to tell everybody roll back. So it's what's the thing there? So if it's an application exception, you can decide what you want to do there. So the best practice is if you've got application exceptions, you're going to call set rollback only. Otherwise, you could have an application exception. So something in your business logic went wrong. Your client doesn't know about it because even if you throw, if your client can still decide if it needs to, but if you're like, listen, this transaction needs to roll back because we're in an invalid state, you need to set the rollback only.
Yeah, but if you throw an exception and it returns out of the mesh, it's going to go to the commit tasks and do the rollback then.
If you do what?
You throw an exception out of the method,
yeah,
it returns out of the method. So if it immediately returns from the exception.
Yeah, but it's going to be an application exception. Application exceptions don't roll back a transaction. So if there's only system exceptions that'll roll it back. Then if you using container managed transactions as well, there's a session synchronization interface, and you use that for stateful session beans, because the stateful session bean can keep state. So you can go and call that stateful session bean a few times in one transaction. You're not just going to call it once, like a stateless bean or singleton method, where you call it one method and you don't call the same one again. So for the stateful bean, if you want that to sort of partake in a transaction, you want to know when that transaction started, when it ends, you have to implement the session synchronization interface on that bean, so that the stateful bean knows when a transaction started, when it ends, and then you can decide what to do there. So you can go and see if it's been rolled back. Because that's sort of one of the things, something happens on the client, the stateful bean isn't going to know about it unless you tell it. So if the session synchronization interface, that's the way the stateful session bean knows what's happening on the client side of the rest of the transaction. So it's got a after begin, so it means that, listen, yeah, we're actually part of a transaction, so you can do whatever you need to do on the stateful bean with that. And then the before and after completion is before it commits, so it's actually when the client is done with the transaction. Before that transaction is committed, you can go and check anything else. And then after completion, also go and see if it actually was committed, because something else could have rolled it back, and you can do whatever you need to do on your stateful side. Then just some best practices. So I say sort of the default for beans is container managed transactions with a required attribute, and they sort of reckon that's a very safe setting. You don't necessarily need to go and change things unless you want specific things, but that'll be safe enough for most of the times. Then when you if you're setting up any type of business logic where you're going to have a few beans calling or a few things happening in one place, it's sort of best practice of one method that's sort of the entry point for that. So in that method, you can sort of set your commit and rollbacks and your exception handling instead of having it all over the place. So that one method can go and sort of be a workflow sort of method for the rest of it. So instead of having your catch exceptions all over the place, you can have it in one place there, sort of as an entry point. So we've mentioned as well that get rollback only to go and check before you perform any long-running tasks. If you are going to be using those attributes, setting the most restrictive one on your class level, because you can go and override those on method levels. So if you accidentally don't set something on a method level, at least you're not going to have any unwanted consequences from that. I said that transactional propagations, that's sort of knowing that if a client has already started a transaction and it calls a bean that's sort of mandatory, that bean means it's going to actually take part in that transaction that's already started. And as I said, that whole little scenario they give you. So you need to be aware of that and how it flows from bean to bean and when a transaction started, when it is suspended, when it starts again. And then just be aware that transactional contexts aren't available in all methods. So you can't necessarily go and use it everywhere, so especially the lifecycle callbacks. And the lifecycle callback, it's not part of a transaction at all yet. So that was quite a lot of talking. So just do a quick demo around the container managed transactions. So there's any questions or anything on? There's one. Windows says a new Windows version released for insiders. If you want to try that. There's a new Windows 10 version released for insiders.
I'm running 10 Enterprise. I tested everything. JBoss, Eclipse, Maven, everything works fine. Doesn't work for my drivers, but it works fine as well.
All right, so for this demo, I've just got a controller here. Just use the REST services again. So I'm using some of the attributes here just to simulate there being a transaction, not being a transaction, so you can ignore that. So I've got two methods. One that the client has a transaction, and one where the client doesn't have a transaction yet. So I'm saying not supported, so it's not going to actually start a transaction. And it's calling the same method on the bean. So I've got a contain transaction bean here, which has just got a method that's going to do some work. All right, so to get this going, you set your transaction management attribute on here. I say if the default is a container, so it's actually redundant. If you're going to use container managed transaction management, you don't actually need to put this on it. That's a default, but you can put it on. And then if we go onto our method, we can say transaction attribute. I can set that to required. So that means is when we call our bean, we actually, if there isn't a transaction started by a client on there, go and start a new one and get it and do it yourself. All right, so that's what I want to show you. You can see sort of the whole thing around transaction managers, especially the container managed stuff. It's quite simple to use. It's just a transaction propagation, knowing the different attributes. Now that's where the difficulty comes in, and where they try and trick you up. Me.
Like totally abandoned last page.
Last page burned me. I don't know. Actually, maybe I don't know what I did. I broke something on my instance. I should probably just get a new one, but it's almost just been easier. Let's see. Okay. See, where's Postman? I started. No, I didn't. All right. So I'm going to call our transaction container. So this is container calling it with a transaction, so it should just work normally. And calling it without a transaction started, it still just go fine. So it just works. But if I go and change this to mandatory, this means that any client that's going to call this method has to have a transaction running. So if I don't have a transaction running, this is going to throw a EJB required. What's the, I can't remember. It's going to throw a EJB transaction required exception. That's it. So actually bold this. For an EJB required exception. So I'm just going to repackage it. So what should happen is if I call the method with the transaction, that should just work like it did before. So you see no exceptions. Then I'm going to call the one without an exception. We'll see that we've got an EJB transaction required exception that was thrown. Since I'm actually catching that over there. So that's been thrown. So that's pretty much it. That's container managed transactions. So it's really just the transaction propagation that's really difficult when it comes to container managed. All right, so the other one is bean managed transactions. So with container managed transactions, you sort of set up your boundaries for the transaction with sort of the start and end of your business methods. Or if you're using a stateful bean, wherever your client starts and stops it. When it comes to bean managed transactions, you kind of do your transaction the same way you do with any of your database type commit rollbacks. You know, you start a transaction, you roll it back, and that's where you set your boundaries. So your container still takes care of the actual transactionality for you, but you need to tell the container when to start and stop your transaction, when to roll it back. So to do that, your transaction type management type is set to bean. If you're going to use bean managed transactions using your user transaction interface, and you haven't set it to bean, it's going to throw, your container is going to throw an exception. And the other thing that's important is whenever you call a bean managed, a bean that's using bean managed transactions, transaction management, whatever there is a transaction that's been started, it doesn't propagate to that bean then. So it sort of gets suspended before it goes into the bean. So that's just another thing you need to know. So the thing about bean managed transactions, you need to use it sparingly because you're in charge of the taking care of the transactionality then. And so the whole thing of container managed transactionality is that it takes care of it for you. You don't have to worry about it. Adding that into your business logic, then you've got business logic and this transaction logic that's all over the place, which will sort of makes it a bit more complex. Other places to use it is if you've got something like a stateful bean that you are going to call. Like, so with a stateful bean, you don't want the transaction to necessarily go and commit every time you finish calling method on that stateful bean. You can use a bean managed transaction for whatever bean is calling that stateful bean to sort of make sure you finish whatever you need to do on that stateful bean and then only commit it. And you can also go and sort of fine tune that transactionality. And the only reason you might want to do that is if you've got some really weird performance issues, which I think points to something else actually, but you can sort of do something like that. I actually mentioned there, like it's premature optimization. If you're going to put those things in ahead of time, so you're sort of saying, well, I'll just lock this database for this little bit here and then commit it, and there's probably bigger problems in your application architecture. But you can do it for that. So the way that you do the bean managed transactions, you go and mark your class as being bean managed, and then you use a user transaction interface to start and stop your transactions committed and roll back. So you're going to get that free injection, so injecting it using a resource annotation. Doing is using a GIND lookup, actually getting it from your EJB context. And this is sort of, resource is probably the better way to do it, or add inject, I think you can use as well, if you're using JE7. So with that, you can do your begin. That's a beginner transaction, same you'll do with a normal JDBC type transactions. And you can commit to rollback. You can do the set rollback as well. Like I said, it's sort of used when you're calling a container managed bean with a possible long running process. So if you're going to roll it back and you're going to call another bean, it's just for optimization. Then you can also do a get status. So in that bean, you can go and see, listen here, what's happened to the transaction. Because it's part of a distributed transaction, you can go and see if anything else has rolled it back. So you can go and see what's the status of your transaction. If you need to start it, not start it. And there's a few there. Is it active? Has it been marked for rollback? It's prepared, committed. So you don't necessarily need to know this for the exam. Just know that it is possible. And then you can also set your transaction timeouts. So that's sort of waiting for, listen, I need to commit it. How long should I wait for this? And this also just comes to optimization. Not so much optimization, but you don't want to have a client calling your bean and then doing a commit and then that commit sitting for a minute waiting to commit because there's some other lock somewhere. You know, just to keep the interactiveness of the application going, you probably want to set a timeout there. The same thing as we did with the JMS stuff with the messages. So you've actually, when you're looking for a message, not to let it sit and look for the message for you, but actually time out after a while. And that's it for bean managed transactions. So sort of it's knowing when to use it and using your user transaction interface to actually start to commit those things and being able to look at the bean managed stuff. Oh yeah, no, I remember there's actually one other thing I wanted to show with the container managed. So before we do bean managed, actually there's one more thing I want to do with the container managed, and that session synchronization interface. So got a stateful bean here. I've implemented session synchronization interface on. So it's also got a method that's going to do some work, and we've got our after begin, before completion, after completion methods there. So if I go into my container controller here, I'm just going to use the stateful bean here. So what we will see in the output now is we should actually see the log file showing us after begin, before completion, and all that in there as well. Okay, so I'm just going to call the with transaction. So you can see before we're doing some stateful work, the calling after begin is called first. So that's sort of telling your stateful bean, listen here, a transaction has been started, you're part of a transaction, and that gets called before we actually do any work. And then we can see it actually exits the transaction, that method, and then only the transaction gets committed. So that's sort of where that boundary is. And we've got our calling before completion and calling after completion. So that's just showing that session synchronization. Also showing that your boundary, your commit only happens when that business method is exited. So we're going to look at the container control that sort of says that exiting transaction is the last thing it sort of does on that method, and then only it gets committed. Okay, so getting to the bean controller. So here on the bean, we're just going to have something that commits the transaction. So I've got a bean here that does some work, and you can either tell it to commit the work or not commit it. So first we need to do is we need to go and mark this bean as a bean managed transaction. Transaction management using bean, with bean itself. So you need to do that if you want to use your user transaction interface. If you don't specify it as a bean, it's going to throw in an exception if you start it up. Inject it by a resource. User transaction. If I use a transaction, I have to start it. Begin, sorry, start. One thing is it does throw exceptions here, so you need to check the exceptions. You need to either catch or propagate. I'm just going to catch them. It's got a not supported exception, so that's sort of if you trying to start a transaction, but whatever is going to use it doesn't support transactions, you'll get that, and then just normal system exception. I'm just going to put this around everything. All right, then I say in our commit work, I actually want to go and commit this. So I'm going to use transaction.commit. It works the exact same way if you're using, like when you use your normal JDBC type drivers. It's also got some exceptions. So I'm just going to add here. So it's got a heuristic exception. So the heuristic exceptions get thrown from your transaction manager. So a Heuristic mixed exception will be thrown if your transaction manager, as part of the two-phase committing phase, if it actually says, listen, guys, can we commit? And one of the resource manager or more says, listen, actually, I'm going to roll back. So not everybody's committing. That will, your transaction manager will actually then throw a heuristic mixed exception. A heuristic rollback exception happens if people saying, okay, we're committing, and then while they're committing, one of the resource managers throws an exception and rolls back. Then you'll get a heuristic rollback exception. And then your rollback exception is just a rollback exception, which is something I've got in the slide somewhere. What happens there? So that heuristic exceptions, just be aware of them, but they're not going to ask them in the actual certification exam. Well, I don't see them. Let me rather say that. But be aware of them. We've got our commit and our rollback. And that's it. So bean managed transactions, go mark it as a bean, transaction management type bean, and then you use it the normal way you'll do any transactions like with JDBC. Begin, commit, rollback. All right, so let's start it up. And then I'm going to do the bean one, so just the bean commit. You can see it was pretty boring, but it does the work and commits it without throwing an exception. And if I do the rollback one, it goes and rolls back, and I think there's no exceptions thrown or anything. So it's pretty straightforward and simple. I say sort of in the certification, it's all about the transaction propagation and trying to trick up with that. The way these things work, or they might do a commit before doing a rollback, begin transaction, stuff like that. Then the other little bit I just wanted to show you is that get status. So we can go and see an if statement. So if user transaction dot get status equal to status dot active. So if we've got an active transaction there, and just log it. Say action started. So this shouldn't actually return anything, and if we do after begin, it just actually return something there. So if I go and let's call it doesn't matter which one I call. Oh, there should be 2. That doesn't help. We change the number there. Try it again. Hopefully at this stage, just on a bit of the Tommy stuff here, you guys have got sort of a way that you play around and test with the stuff when you're sort of going through the study notes, either using Glassfish or Maven. If you're not sure or you haven't actually been able to get this working, don't just drop me or an email so you can just get it going, because you need to play around with the code and actually code and try things out if you want to be successful with the exam.
Or live.
Live as well, yeah. All right, so you can see it says transaction started, and it's only the second one that shows it. So that's just how you get your status and check the status there. I think that's it for beans. Transaction management. Management. I don't know if you've ever seen that. Trevor Noah, was it Daywalk or something? Management. Transaction management. So the last one I just want to look at is exception handling. So this is one little last topic on that. The main thing, there's exception handling, and exceptions sort of throughout all the other topics that you need to know what happens when exceptions are thrown and what topics exceptions can be thrown. But then this sort of is just sort of the difference between application exceptions and system exceptions. And that's sort of the only thing you need to know specifically to exception handling. So application exceptions, I'm not a fan of using application exceptions unless you've got some other weird API. But using exception handling to sort of say, well, something was successful or not, I don't know. I don't necessarily like that, but that's what you use application exceptions for. So application exceptions just means that your system isn't in a weird state or something went completely wrong. It just means some business rule was broken, and the way you're handling that is by throwing an exception. So you might do it if you've got like an API where the client needs to decide what they want to do in that case, whichever way. So the main thing is application exception is either a checked exception or it is a runtime exception that you've marked as an application exception using that annotation. So the only reason you want to do that is if you don't want to have a checked exception, but you still want to be able to throw an application exception. If you've got a runtime exception that you've marked as an application exception, it won't roll back to any transactions. So any application exceptions, if that gets thrown, if there's a transaction busy, it doesn't roll back the transaction. Because the container sees that as it's some business object that happened, it doesn't mean I'm going to roll back the transaction. It doesn't mean we're in an invalid state. It just means some business object didn't happen. So if you are going to use a runtime exception that you're going to mark as an application exception, you actually need to go and set if you want that to roll back the transaction. So you've got two additional settings there. So it's a rollback setting, which default is false, and an inherited behavior. So if you've got exceptions inheriting from other exceptions, which is also crazy, you can go and actually mark if that rollback behavior is inherited by another exception. Yeah. Yeah. So if you've got exceptions inheriting from exceptions, then step away from the keyboard and go and do something else.
Data power.
So that's application exceptions. So main thing is they don't roll back exceptions, and if you want, and they're checked exceptions. If it's not a checked exception, like a normal runtime exception, you go and mark it as an application exception, and then you decide what you want to do there. So system exceptions are non-application exceptions. So it's either runtime exceptions or remote exceptions. And generally, a system exception is unexpected, and it's also unrecoverable. So it means that if you don't roll back, the system is going to be in a state that it shouldn't be in. So either you've debited one account, but it didn't credit the other account, that type of stuff. Also, application exceptions, you'll expect the client to handle it. From a system exception, the client should be, oh shit, what happened here? I didn't expect that. System exceptions also, generally you don't want your bean to catch those. Those should be propagated up, because if your bean catches those, it means that nothing else knows that shit's gone down. Something is wrong here. You know, so you're hiding those exceptions. That's where things happen and nobody knows why it's happening, why is this not working, and then you go into the code and then you find some okie decided to go and catch a system exception because he wanted to stabilize the system. So don't do that. Also, when a bean throws a system exception, it actually goes and wraps it in an EJB exception. So from your client point of view, if a client wants to catch that or handle that, you need to catch an EJB exception. If you actually go and try and catch a specific system exception, it's not going to happen. It's just going to go past it. And then the other thing around exceptions, and this is where the sort of bits that's strewn throughout the other topics, is knowing what happens when an exception is thrown. So on a singleton bean, if a singleton throws an exception during a BIS method, it doesn't kill the bean keeps living. Where something like a stateful bean, if exception is thrown, the stateful bean dies. It's gone. So that type of stuff you'll need to know. And that's it. So exception handling, knowing the difference between application exceptions and system exceptions, and how to handle that. So I'm going to do a quick exception demo. So I didn't go and do my own one here. I actually took the certification master one, because I didn't think you guys wanted to just sit here and watch me write exceptions, because that'll suck. So with this Maslovsky's little demo, what he's got is he's got a bean, an account bean where you can withdraw money from, and there's 3 different exceptions that can be thrown here. So one is if the bank isn't equal to ING, it throws a connection to bank refuse exception. And if you go and look, we can see this is runtime exception, so it's an actual system exception that's going to be thrown. The other thing it does is if you say it's a loan account, it throws a no cash on account exception. And this is a runtime exception. So it's like a system exception, but it's marked as an application exception. with rollback true. So that rollback actually says if there's a transaction, even though there's an application exception, roll back. And the other one is a can withdraw exception, which is a straightforward application exception. So it won't roll back any transactions on there. So that's what the sort of bean does. And then there's just a controller which sort of catches the different and calls the different methods. So the only thing I've done different here is I'm actually just catching the exceptions. The way he had it initially was he doesn't catch it, so then the log is just full of exceptions, and it's kind of crazy to try and figure out what happened or just to show it. So all of these sort of look for the same exceptions. So that cannot withdraw exception is a checked exception. So you could have I could have either have caught it, or I would have to actually mark it on my method or make it part of my method signature there. So let's just bolt on it. Let me just package this again. Stop that one. That's it. I don't know why it does all this stuff with posts instead of a get or something. Posts. This doesn't matter. I don't like it. Okay, so the first one. Let's see. I've got. So the first method we're going to call is the normal call with the bank as ING, and the amount is less than 700, which is checking for. So this method will just do the normal withdrawal, no exceptions. So this is standard behavior. If we then go and actually make this more than 700, it'll throw that not enough money, not enough cash, cannot withdraw exception, or no cash in account exception. Which one? Can't remember now. And throw the cannot withdraw exception. So that's an application exception. So if I go and call that now, we can see that the cannot withdraw exception was thrown, and that's an application exception. If we go and do the same one, but actually say it's a loan, it's going to throw the no cash in account exception. So you can see there, no cash in account exception was thrown. Like I say, that's a system exception, but it's marked as application exception. And then the last one is if the bank isn't ING, if it's a speaker L1, it's just going to throw a, like I said, it actually throws the, what's the thing now? Connection to bank refused exception. It's a system exception, but on the client side, we can see it picks it up as an EJB exception. So even though I'm looking for an EJB exception and a connection to bank refused exception, because in the system exception, it gets thrown by the container as an EJB exception. And then inside there, you'll have your connection to bank refused exception. So it's the only sort of funniness around system exceptions is that it gets wrapped in EJB exception. And that's it. Exceptions and transactions. Any questions? Wemba's got a question. So Wemba, sort of BMH transactions, since interceptor becomes the part of the beans, is it possible to use transaction on interceptors around the proceed method chain? Yeah, so if your interceptor beans, if you've got a transaction that you've started there, or like with BMH transactions, it won't necessarily be. So you can probably start your transaction in your interceptor class and then commit it out in your interceptor class outside as well. You can do it like that. And that's if you want to do some funky framework like the stuff at APSA. So if you want to sort of simulate container managed transactions, but I mean then you might as well just use container managed transaction management. Yeah, so you might as you can do it like that, but then you might as well have used container managed transactions because that's what you're pretty much simulating there. If that answers your question, Wemba. Cool. Okay. Yeah. Yeah, but you can do the same with container managed. You can use a set rollback. You can do it like that as well.
It's mainly for speed. When you low-level bean transactions, I've never seen it really used other than for speed, or you know there's a performance problem or a problem with the API, you want to handle it yourself.
Yeah, so you might have some weird resource, some old legacy system that might be slow. You know,
or like we've seen, there's a purposeful sleep 10 seconds somewhere that you want to handle.
Yeah, so I was going to say best practice is container managed, and being managed should be the exception for you to use. All right, so the other thing that I keep on forgetting, that I want to show you guys, is on the Enterprise Java Beans, the one study guide, they've got this annotation summary at the back. And especially when you start looking for training, studying for certification, is to go through these annotations and actually see if you can identify now how all of these are used and where they're used, what the intricacies are, and so on. So knowing what local bean, local or remote means, when that gets used, your different session beans, what these different annotations mean, that you understand them. And I think if you can sort of go through this one pager and you understand to know each one of these, know how to use them, I think you're pretty good on your way to do well in the certification. So this is a good sort of resource to use to check yourself. It's going through these, and if you look at one of these annotations and it's sort of, what does that annotation mean? You probably go and check and study up on that. So for this week, we're doing the quiz. We're doing the quiz a bit different. So it's not a quiz that we're going to do on Moodle. So you're actually going to use the ETS mock exam for it. So it's important that you go and check that you've loaded and started your ETS viewer, that you've got it. If you haven't or you've been struggling with it, you have to let us know. Please don't come Monday and say, I didn't do the quiz because I didn't know how this works. Or I couldn't get the ETS viewer. So go and check it now, today, this morning, or tonight, or tomorrow, but before the weekend, and see that you've got that running and loaded. So the way it works is on this week's review exam, we don't have an actual quiz. If you go in there, there's a list of question numbers that you need to go and do, and there's 20, if I remember. There's 20 that you need to do. So you can pretty much just go and copy those lists of questions. On the info test studio, on this ETS viewer, you've got your custom test at the bottom there. So you go to custom test, and you say you want to create a new one, and you can give it a name. So like that. Then when you have to set up your questions, you say it's hard-coded. It's going to give you a pop-up box. You paste those numbers in there, click OK, and you're good to go. So you can save that. And then when you want to write the test, just double-click it, say you want to start. I don't know if there's a bug in there, but it doesn't start it when you say start. It just puts it on there. And then you just go continue test and you start your test. And that's it. So when you I know, I don't, maybe yours isn't the latest version. Maybe Windows 10 fixed it. So there's 20 questions, and you've got, it's like 37 minutes or something. So it's a little bit less than 2 minutes per question, which is what you're going to have for the exam. This transaction one isn't too difficult. Like I say, sort of one place you might want to have a piece of paper and pen together is where we look at the transaction propagation. So there's a few questions like that. So actually going and marking it out. So if you see a question like that, read the question, read the scenario, and actually map it out on the paper before looking at the answers. And then going and seeing, okay, well, this is what I think it should look like. Then go and look at the answers and see, listening, does any of this match? That'll be less confusing. Once you've done with the exam, just take a screenshot of your results. So it needs to be, you have to have more than 50%. So if you get less than 50%, you have to rewrite it. So we write it as many times. Hopefully the second time we'll get more than 50%. If you don't, then I don't think EJB is your problem. Alzheimer's might be. But might just write this test. All right, so next week is the last week, and we're doing 2 topics again, timers and security. So a bit more reading up ahead. Next week, we're also going to try and start at 7 and not 7:05, because I just want to go through preparations for the certification exam and extra things to look for. So we're going to have a few extra slides on that. Now, security timers. If you're going to do the Whistle certification, security is a good one to study up on, because there's quite a few questions on that.
Maybe come to Whistle certification now also.
So there hasn't been an official email, but we are going to be doing the Whistle certification. And like I said, so if you want a challenge, that's a good one. The WSDL certification, what's actually nice about it is it goes into more than just the Java side of REST and SOAP services and that type of stuff. It actually goes into the technology and best practice around SOAP and REST. So you'll get a lot out of it, not just this is the way it works in Java, like of EJBs. EJBs, there's not a lot you can sort of transpose from EJBs to other technologies, but with the WSDL one, there's quite a bit that comes out of it. So if you actually know SOAP and REST and so on really well, the WSDL certification won't be too difficult, because the difficult part there isn't the Java technology bit of it. The Java technology bit is actually quite easy. It's the best practices and how REST works in the real world, how SOAP works in the real world, how SOAP security works. And there's some obscure bits in there that you'll probably never use, but I think it's good to know. Low level shit.
Tom.
Yeah. All right, Sue. There's no other questions. No. Okay, so the keyword for today is rollback. Not roll over, roll back. And that's it. There's nothing else. Then see you guys next week for the last class. Cheers.